Hi Jay, I wanted to provide a presentation of the geometric analysis I performed on your body marks this morning after you sent them to me. So I'm working from these photos, that photo, and this photo actually I used in reference as well. So I want to jump to give you a clue as to where we're going. So where are we going? This is a ruler and compass geometric construction of your body mark here. We've got some reference triangles I wrote out so we have a sense of comparison with special triangles. So I want to just walk you through the analysis I've done so that you can see how meaningful the placement of your marks are, the radius, the size of them, the placement relative to each other, and you have a level of understanding as to how specific this geometric construction is. So I'll just walk you through the process. So I got these in email, and then I download them. My idea, like you can see, is to print out the markings and then be able to draw on this to perform the analysis. So here's the photo that I ended up printing out, and I want to talk about that because I took this photo and and this photo. So we have two different angles of the same marking on the body. We also have a third marking that comes from the one that was annotated at a different angle. And so what I ended up doing was I darkened these marks by using the burn tool in GIMP. So it's really not revealing, adding new information, it's just revealing information. I have to get the contrast rather high to print them out to actually see. So that's what I did here, and that's what I did here. That yields, I'll show you, it yielded something like this, right? So then I have something like this to start working with, and I'm trying to make sense of it. I used, in my analysis, right, of these two different marks, of two different photos, I noticed how different they sort of looked, right? And so I wanted to get a sense as to what's actually the difference of angle versus what's coming from the body mark. So that is why I created this image, which, as you can see, has three different marks kind of congruent. And so what I ended up doing was pulling these marks off of each photo, layering them together, and only performing the scale or rotate transforms of the images and selective isolation of these marks so that I can overlay them one on the other. So this gives me, if I average this out, what is our understanding of what the mark actually is as computed from these different images. So this is really important to keep coming back to, because you looking at the different photos, you go, what is what, how far is this, how far is that? And this really gives us a sense that there is a strong congruence, although there's a little bit of wiggle room in terms of the analysis being performed on the printout. All right, so let's get back to the this. So this is one of my first attempts to understand this. I outlined it, and I basically start taking my compass and I'm drawing lines. Is this the same? Is this the same? Oh yeah, that looks kind of similar, right? And then is this the same? Well, they're not going straight through the center of the dots, so it's not necessarily the same. I printed out this photo and I started to get some clues. I started to draw the different circumferences, noticing that yes, indeed, even though the marks are kind of ovoid, yes, indeed, even though the angle is not perfect, like all photographs are, and you have great photographs actually, so of them. So I'm starting to test, is this a circle? Is this the same? Yes, yes, yes. what is here, and I start to try to figure out what are the actual proportions here. So then, let's see. As you can see, I've got a few different analysis going on, and really, when I brought them all together and I printed it out, I was able to get something very, very geometric. And so this has specific qualities that I want to talk about, but I want to just walk through this process with you so you have a little bit of the sense of it. So I'm going to introduce another tool. This is the compass that I've been using. It obviously draws circles and allows you to compare intervals. This interval, that interval, they're the same. So all of the circles drawn with red or pink are the same size. That's telling me there's a whole number ratio between the size of the circle and their distance. I'm using this tool now. This is called a golden ratio caliper. This is used in I don't know, eyebrow plucking and tattoos to make sure things are lined up. But I use that for testing the golden ratio. So that's one of the things I look for in geometric expressions is there whole number ratios, meaning so we have a five dots here, and based on the size of the dot, 5 dot here, and then we see here there is a meaningful kind of relationship, but it's not perfect. And so this bit of irrationality actually in this context of rationality or very like rational numbers versus irrational, this will give us some meaningful resonance with a physical constant or something like a square or square root of something. So that this is a clue for the analysis here, and I'll talk a little bit more about that as we start to orient this triangle within the realm of special triangles. I just want to show you, this is another clue coming up, right? I go, where is the golden ratio, right? So this starts drawing the golden ratio, and I go, oh, okay, is it as this radius is to the center between these two as the radius? Does that make even sense? I'm not quite sure geometrically, but I'm kind of looking at points of intersection, and sometimes I'll draw the line out and I'm like, does this make sense? There's a little bit of wiggle room in the caliper, so I start doing the math too, and I'm just sort of testing where these three prongs line up, because if they line up at intersection points or meaningful points in the figure, then we know it's the golden ratio being expressed. So here versus here, there's a couple of things that I started testing with, and this is why I drew the three different lines on this, is so I could actually start to test. I got to this part where I go, okay, the distance between the dots is meaningful, not necessarily. That was the thing that started cluing me in to a deeper order of meaning here. I'm still sort, it's like from that side, right? And then we're just testing, right? We're just testing. Is there something here? And there's not a lot. I would not say this is about the golden ratio. This has the golden ratio because everything has the golden ratio, but this one in itself isn't about that. And so that's why I was showing here a little bit. It is present. I mean, if you start to work with all of this, you can start to see there's some level of resonance there. But that's like pentagrams have resonance with golden ratio. Hexagrams, all circles do. Everything does. But this isn't necessarily all about that in my mind right now. And that's fine. So I'm saying I'm seeing golden ratio points just like I'm seeing whole number ratios. But this is not necessarily the theme right now. I want to point out here, I'm starting to measure actually. I'm counting, there's 15 millimeters in the radius here, and then I'm starting to do the math on this triangle as well. So this is the clue. This is the thing I want to build, right? So when we have when we do geometry, we go, I want to build something. I want to construct this figure using only ruler and compass methods. If I can do that and line these up one on the other, right? I know they're congruent. If I know they're congruent, I know that your marking is an expression of this geometry. And when we lay them on top of each other, we can use the words QEF, the acronym. So that which was requested to be constructed has been constructed. And that's what I'm really going to get to here. There's one final clue that I wanted to talk about before we start going through the actual construction, which is this purple line and this purple line are equidistant. So I'm going to test that by bringing that over here, pulling up my compasses from center to center, right? And you can see it doesn't intersect with that center, right? Isn't that interesting? And there's almost an expression here, but it is lining up. It is lining up right there. That's like a clue that we have. But I'm showing you this from center to center, from this bisection point to that center. So now we have a really strong capacity to build the image. So these are all the clues I had to do the construction. I have some of this information where I counted it out, and I started doing math on this, right? And well, what are these angles even? So then I had a journey with that, and I'm going to show you that here. So where are we? We are. So I go, this is probably a special right triangle, to be honest. This is so because I'm seeing that bisection line, that bisection right here, that indicates to me that this is a right angle and this is a right angle, and therefore it's a special right angle triangle, and I'll be able to develop the construction based on that. So this is the best candidate, the 30, 60, 90 triangle. You might be familiar with that through 369. People talk about it in terms of Tesla's work. So as you can see here, and we can just zoom in, zoom into this triangle, because this one looks very, 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 very similar to your open image in new tab. So we can just zoom in so you can start to see that. 30 degrees, 60 degrees, 90 degrees. This is bisecting. M is bisecting B to C. And we're starting to see a little bit of a similar quality of your mark. So this I would say is the kind of pattern that I wanted to immediately reference, and I'll talk a little bit more about that journey. So but if we actually do some of the calculations, right, we've got a side A, which would be 34 millimeters in the diagram, side C 72, and side B 64. If we go back to the initial charts, you can see it. We're close. We're really close. I'm bringing in the actual calculations here from the diagram I made on top of your images. We're not at, let's see, we are not, these are the angles, right? We've got 88, 64, and 27. Those are pretty close. And those are likely within a little bit of tolerance of my capacity to draw and measure at that scale. So we're definitely in reference to the 30, 60, 90, but we're not necessarily there. This would be, this is your, the actual, some of the measurements, again, coming up, 72 and 72, 66. I'm playing with these different experiences so we can actually get measurements and test, is this right? Is this a 30, 60, 90 triangle or not? My conclusion based upon the measurements in these numbers is we are close, but this is not that triangle. And the reason why I'll say that, because I'll go back to one of these. This here, let me see if I can bring in some more. I need to bring down the contrast and bring up that apply. Okay, so you should now be able to see my pencil marks here. This is the construction of my attempt at the 30, 60, 90 triangle construction of your markings. So as you can see here, I've identified, yes, this is the radius that I'll use to draw 5 circles along a line. And I know that this is somewhere around 4 1/4 to 4 1/2 of the circle. So now I'm starting to be able to measure and draw this using intervals present within the radius of your dots. So we've got a 30, 60, 90 constructed using not golden ratio, ruler and compass method. And I started to draw this out, and it just doesn't feel right to me whatsoever, right? It looks not quite right. This is too wide. This is too big. This is too whatever in my mind. And so I was working on this, and my wife actually comes in and she says, don't you remember that you had a dream with about nested vesica Pisces, which are the intersections of 2 circles? And I go, I actually did. And then I realized that we have to go back to here, and that this line, this purple line here and this purple line here are the same, and they're at perpendicular angles, which is essential to the vesica Pisces. And I might as well just show you this, but I wanted to kind of reveal what I'm talking about here, because we've got the distance between that intersection point and this point should be the same between this intersection point and this intersection point, but it's not, based on the measurements of equality of these purple lines. So that's what I'm saying, and this is not the case. This is not the construction. It's not a 30, 60, 90. It's very close to a 30, 60, 90, which is a meaningful communication in and of itself that I don't have enough mathematical understanding to tell you what or why or how, but I'm just describing you. There's meaning in this, right? So let's actually go through. Let me show you the construction method, so you have a sense of it, because this is the meaning behind all of it. Is how to relate to it. Is that this is geometrically meaningful. Geometry in and of itself is a mode of communication that, if you go back to where this geometry comes from, which is the foundation of Western mathematics, right? All of Western mathematics, calculus, everything comes up and out of this practice. You go back to that, you'll eventually encounter Plato, who talked about geometry as a means of recollection, and also talked about it in a very, very similar way as talking about his relationship to the daimon, which was a non-human intelligence he interacted with. So we're finding that this here is a geometric communication, that we can establish orientation within a cultural space that's significant to Western culture, in a mathematical space that's universally meaningful, and it's starting to tune into frequencies of communication that have been, at least in the Western canon, have their precedent in non-human intelligence communications. So let's just go through it. So what do I know? I know this is equal to this. So let's start with that, right? So I'm drawing a line. I'm going to say, all right, let's take that distance, and actually let's go through it together, right? Like, I'm taking this distance right off of that distance right off of the chart. which we know is absolutely congruent with your markings because it's from your markings, kind of established in that way. I'm now marking this line with that because I'll show you why. I am going to then draw these circles up. I'm going to draw these circles up like this, like that. So then I can draw, this is the vesica Pisces, by the way, vesica Pisces, and then we are now making perpendicular lines. This is a center. This is this point of intersection. So now, now that we know this, we know that this line to this line has 5 dots. How did I actually construct it? So I've got these vesica Pisces lines, and so now I go, okay, so, I see. We take this distance again, and we apply it here. So now we have our triangle. This is a very simple and elegant construction. Draw that line, and draw this line, right? So now we have triangle, triangle point, and then this is the center point there. That's a source of meaning for this communication. So now we just have to figure out how do we draw the size of your dots in proportion to this triangle that's very, very well established. This triangle emerges out of, you can draw it very, very simply out of any proportion, right? So that any distance, right? This distance is very simple. You just take the compass and you apply it again in this way. So how do we do this? Well, I know that I'm just going to work with another intersection, right? So now let's actually start using the colors because it gets confusing. So we'll draw from here down to here, and from here to there. Those should be equidistant. Let's actually test that once again. That to that, that to that. All right, it's tested as they're same distances. So then I want to bring in the light blue because that's what I used in the diagram. So now we get to draw the circles in. How do I do this? Well, I know, right? I can see if there's 5 circles along this line. I know that one's at a point of bisection, and this one's at a point of bisection as well, because you can see it's odd number circles on this line, and that the radius is the circles meet at another bisection point. So I just have to do like for vesica Pisces, which my dreams told me this morning that my wife reminded me of as I was trying to build this with a 30, 60, 90 triangle. So let's go ahead and do that by, we're going to simply take the distance of one of these light blue lines, which is the side of the triangle, and let's see, I'm going to then draw a circle around it and another circle around it. And so now we have this point and this point that if we connect it, will bisect that line. Right, so now we have, let's orient it in time and space. We have the placement of that circle. We now have to place this circle by bisecting this line again, which is this line, which is easy enough. We'll draw our third vesica Pisces. And I love how this sort of stuff happens where that circle lines up with another point. This is revealing the kind of geometric coherence in your marking. So once again, we've got that center of the circle. That's the center of the circle here. The center of your dot is the vertex of the triangle. This circle is placed by bisection there. And the reason why these circles are meaningful is they're the same size as your dot, and they fit so beautifully together. All right. We need to do one more bisection to get the radius of the dot, right? So, once again, just sort of do this construction and this construction. So now we have 1, 2, 3, fourth vesica Pisces. How beautiful is that? And we bisected that line. That gives us the radius of your dot. So let's go ahead and pull that up. So this is another congruence test, right? So I am now going to draw your circle. This is the first dot in your triangle. Like, okay. So now I can take that and I can just draw it here. And I can just draw it here. And we've got your mark. At this point, we can say QEF. But I just wanted to show you, right? So now I've drawn, look at that. Look at that, right? Look at that. This is, I'm identifying the radius of your dots based upon a geometric construction. The only measurement I derived from your marking was this purple line. That's a congruence test that says your marking is a geometric object, right? And this is what your the geometric object is. So if we wanted to complete the kind of drawing I have, you would just draw circle, circle, circle along the lines to reveal how many circles there are. But why don't we just take this right now and kind of go like that, because this is sort of what happens in the marking process. It looks like there's a beautiful geometry and then it's put onto the body somehow. So that's the construction. This is the clue. There's congruence tests between them. We could take photos and overlay them once again, and we don't need to do that, but because it's here. I mean, you can see it right now that there is geometric meaning within those marks, that it is reminiscent or expressive of a 30, 60, 90 triangle, but isn't. However, it does express regular proportions. This is, we've got 5, 5, and then this is actually something like 4.33. That's another clue. It's meaningful that like 432 is coming out. There's other numbers that come up and out of this when we start looking at it in different ways. Trying to think if there's anything else. You need to know about this, and I don't think so. This is the construction QEF. You've got a geometric mark from Orb on your arm, and this is a source of meaning. This needs to be looked into. What is this? How is this? How does this compare with a 30, 60, 90 triangle? That will provide a sense of meaning and also a sense of adventure and inquiry for you as you develop your experience. If this isn't news to you. So thanks for sharing that with me, and yeah, we'll be in touch.